This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber and today we have a special episode because we have two different guests. So in the main section we have Phillip Lippe from the Google Gemini team. That's a real honor to have him on the podcast. And in the news section we have an old friend of our podcast, Timo Gessmann, CTO of Schunk. And Timo wrote us a few weeks ago and said, hey, I want to help shape the future of robotics and I need AI experts at Schunk. We are happy to help. That's why Timo is presenting his plans now in the news part and then in the main part, Phillip Lippe. Enjoy listening. Timo, welcome to the podcast.
Yeah, hi Robert. Great talk to you.
You wrote us because you listen to us and because you need people who want to develop AI with you. We are happy to help you. But before we do that, please introduce yourself briefly to the listeners, Timo.
Yeah, my name is Timo. I'm working at Schunk. I'm responsible at Schunk as CTO for all of our product developments. So we are a family-owned company and we develop products, especially automation products for all kinds of robots, including grippers, automation portfolio, and also robotic hands for industrial robots, for cobots, HGVs, but also for humanoid robots.
Yeah, that's very impressive. Your robot hand, right? So this is the Champions League of gripping, right?
Thank you so much. Yes, exactly.
So let's talk about AI, because you mentioned gripper, grasping solutions, automation, add-ons. But when it comes to AI, tell us, what are you working on?
Yeah, as mentioned, we are a family-owned business. We started 8 years ago in the field of mechanical. So we are a mechanical engineering company, produce a lot of mechanics. But over the last 15 years, we learned that also software, embedded software, and also nowadays, of course, AI is crucial to solve automation processes in all kind of industries. So what we are doing, we combine our mechanical expertise together with software and AI to develop completely new products in the field of robotics, with the aim to enable automation like in industries, in electronics, in life science, medical, logistics, and also up to service robotics. So I think there's a huge potential currently to bring together mechanical products with AI. And it's like a human being, so we have to have a very good body, but also, of course, very good brain and learn every day new skills. And now I see there's a huge potential to use these AI skills to enable automation in all kinds of industries.
Why is it so difficult for you to attract people in the field of, let's call it, industrial AI, combining mechanical engineering and AI competence?
That's a good question. So from my understanding, as mentioned, we are family owned, so we have a long expertise and we are very strong in mechanics. And that's also what we are known for, that we produce very good mechanical products which we deliver globally in all kinds of countries and all kinds of industries. We are not yet well known in the field of software and AI. But yeah, unfortunately, that's like that. We are working on that to get a greater network. Since also for me, I worked in the past also for huge companies like Bosch. And now, since 6 years, I'm here within Schunk, and I enjoyed very much, since in a family-owned and, let's say, mid-sized company as we are within Schunk, we can develop a lot of new products. We have a lot of freedom. So we are very also entrepreneurial mindset. We are very close to the customers. And there I see a great chance to bring AI expertise and AI knowledge into our company, and with that then for the people working for us to the customers, and combine, as mentioned, those mechanical strengths with AI strengths.
Can you share some, let's call it maybe topics, because you already use AI in your grasping toolkit, for example, in your grasping solution, you won a big prize for that. And you are a ROS first company, as I recommend. But can you share some AI topics, some AI time horizon, what you want to achieve, what kind of topics? Is it world robotics models? Is it VLA models? What is your aim to do?
Yeah, it's a very good question. So roughly about 7 years ago, we started with existing with the, let's say, with the good old classical AI algorithms, which we use there to do grasping solutions. So we use AI integrated in our grippers and also in the robotic ecosystem to, for instance, to detect industrial parts and learn how to grasp objects. So, for instance, if the robot sees with his camera, let's say a battery cell, then with the help of AI, we analyze the object and do the grasp planning. So that's where we started with the good old fashioned classical AI. But nowadays, as you mentioned, we also work and use robotic foundation models. Since there we see a huge potential that we enable the robot and the system, and especially our grippers, our hand, which is a very mechanical complex topic with a lot of degrees of freedom, where we can enable the hand in the robot by using robotic foundation model to make it more versatile and more generalizable to solve a lot of different grasping tasks which you need outside in the real world. So as you know, there are a lot of robots outside which can walk, which can detect the environment and see the door and walk through the door and something like that. But for us, it's more about to have the physical interaction with the real life objects. So our hand has to detect the object and has to define what is the best grasping method to interact with the real physical world. And there we are. I have close collaborations as well with startups, with universities, but also with companies well known like NVIDIA to bring this physical AI and embodied AI with the kind of robotic foundation models into real life industrial products. And that's what we're currently working on. That means we bring those AI foundation models into our quivers, into our systems. And also what we are offering since this year, we also have complete automation cells.
Turnkey solutions by Schunk.
Yes, exactly. Also turnkey solutions by Schunk. That's what we showed this year at Automatica Munich. So we not only provide the components like a gripper, we also provide a complete automation cell where we combined our mechanical expertise and also the topic of AI and software to enable complete processes like laser marking, like handling of objects. And there I see a huge potential to combine the mechanical strengths with the AI foundation models and also this topic of physical and embodied AI to make it happen, to provide solutions to our customers.
You mentioned now these world robotics models of foundation models, but the guys who are working on these models, NVIDIA, Meta, Toyota, there are a few more, and I don't see so much robotics companies doing research in this field. Or am I wrong, Timo?
I think it's very important that, or whatever, let me say that I think, yes, you're right. There are a lot of companies working with those foundation models, and you have to really seek for the companies and also for robotic companies which are active in that field. The nice thing about Schunk and our products is that we are collaborating with all kinds of robot manufacturers. So like industrial robot manufacturers, but also the cobots and the humanoids. And we also collaborate, as you mentioned, with the well-known technology companies. So we have a broad view, and I'm not allowed to talk about any detailed projects, but of course there are players outside, especially in Europe, but we're also very active in US. And also 2 weeks ago, I've been in China visiting all those relevant partners and companies where we collaborate.
But when I see the term world robotics models, it's always connected to Google, to Meta, to the big US players. Why is there no ambition in Europe to say, okay, now we will build world robotics models together, not a world robotics model by NVIDIA or by Google or by Meta? Why is there no ambition to do that?
Yeah, that's a good point. And the good answer is yes, there is ambition. So we initiated 2 years ago together with some huge manufacturing automotive suppliers, but also with players active in the field of data centers, AI, and software, like here in the region. So our company is based next to Heilbronn. Maybe you heard about EPI, Innovation Park by AI.
Sure.
And there we have a huge chance and a huge network to bring together companies, experts, students, universities, and startups to do exactly what you mentioned, to establish European-based industrial robotic foundation models. Our expertise And I really see a very good chance for Europe and also for especially manufacturing companies like us to bring those industrial process knowledge and manufacturing process knowledge, to use that to train those foundation models and bring that knowledge into the foundation models.
So foundation model is a huge topic. Can you share some of the time horizon? Is it something for 2 years, for 3 years? And what will be the bread and butter business when it comes to AI if I want to work at Schunk?
Yeah, as you know, the topic of AI is evolving very fast. So let me give you an example. 2 years ago, I visited actively the NVIDIA GTC.
Oh, we met there.
You met us there. I also was there the year before, and we showed there our robotic cell together with NVIDIA to show how can digital twin simulation and AI enable real life processes in a manufacturing company. And we all know there is still a lot of sim to real gap, but over the last 2 years, AI and especially the foundation models evolved a lot. So every day we learn something new and we see how good they are working. We also have currently also projects running. Robert, you know, with a company from Austria.
Oh, I don't know this company because I'm biased in this situation. Yes.
So what I want to say is we collaborate with different companies. We use classical large language foundation models, but also models which are focusing on time series data. And we see there's going on a lot of things. And for us at Schunk, it's important to have to know those technologies, but also to use that technologies for real life applications like we have in our company, like assembly tasks, like tasks for our intelligent tool holder in a CNC machine to optimize the machining process by using our hardware components, like a tool holder. But we integrated there a small sensor, a MEM sensor, to measure in real time vibration data. And by using now AI, we can optimize the CNC machining process with the help of AI to find the right parameters for the CNC machine. So we can provide better quality and better output of a CNC machining task by combining mechanics, software, and AI. And that's for me a game changer. And also there we learned a lot over the last 4 weeks that now things are possible with the new AI models, which will not have been possible last year.
I don't know what happened in this 4 weeks. Let me come back to one point to the robotics I'm very interested in. I don't understand why from my point of view, the entire robotics industry relies on NVIDIA. Isn't that a vendor lock-in to go only with NVIDIA?
For us, it's very important, as mentioned, to be open. So I agree. So for us, as a supplier of like robotic hands, it's crucial to be open for the OEM sites, like the robot OEMs, but also for the technology we are using. So whether it's NVIDIA or other players. So I completely agree. That's why we also share our knowledge with open source. Like we are very active in the ROS environment. So for us, it's key and crucial to be open and to contribute also to the cross community and use technology which is outside there. And as mentioned before, that's why we initiate also this European initiative that we can have, let's say that we have a huge toolbox of AI models which we can then put together for the application. And if the more toolboxes and the more models are outside there, it's great. Then we have a huge, let's say, a playground to take the right model for the right application.
Can you share at the end, what is your vision at Schunk? What does Schunk look like when it comes to AI in 5 years? What is your aim, your goal?
Our aim is to use AI models and the mechanics which we provide to combine those, and by the strength of mechanics and AI to enable automation in all kind of industries. And that's the great chance which we have within Schunk, since we are active in all industry branches, as mentioned, from automotive, wire electronics, medtech, aviation, and also logistics and service robotics. And I see there's huge potential to, especially in the field of robotics, since the robotics is a physical product, you need great physical products, but you also need the AI, like the brain of the human, to be very versatile. And that's what we want to develop. We are a very good way on it, but of course still have some open positions. So we are looking for people. Welcome joining the Schunk company.
And when we will see the first European world robotics model?
I hope we will see it very fast and very, very shortly. So as mentioned, we're already working on that. So yeah, please join our company, then you will see it. And
That's the trick. Yeah. So you need to join and then you will get more information. Thank you, Timo. It was a pleasure as always. And now we move on to the main part with Phillip Lippe from the Gemini team. My name is Robert Weber, and it's a pleasure to talk to a very special guest, Phillip Lippe. Hello, Phillip. Welcome to the podcast.
Thanks so much for having me.
Yeah, I'm really looking forward to talk to you because we met, I think, 1 year ago at NXAI in Linz, and I was so impressed by your work, but I was also impressed because you are a Schalker Jung, and I'm also a Schalker Jung, and that's our connection now. But you are now based in Silicon Valley. Before we start talking about Gemini and your work, maybe you can please introduce yourself briefly to the listeners.
Of course. So I'm Phillip. I'm a research scientist here at Google DeepMind. I joined in January recently and working mainly on like core Gemini and most recently, for instance, on the Nano Banana model, which was doing a lot of native image generation. Before that, as you already mentioned, basically I had a short stint at NXAI and was doing before that a PhD in Amsterdam.
And why do you focus on Gen AI and these topics? There are some voices in the community saying, that's a one-way street. So why Gen AI? Why is it so fascinating for you? And why do you focus on Gen AI topics?
I think Gen AI is like also still quite broad actually, because we have multiple modalities on the one hand to consider. I mean, we have text, which is where the language models currently became very big. But the other side is also like the images, videos, and everything. And I think on one hand, what always interests me is also basically to be able to create something. Let's say, for instance, to create a video, you need to have actual word understanding. You need to know how actually physics work, how actually different things interact. And this is something that, like, I think for me is also the main motivation, that actually through Gen AI, you get a lot of understanding. And this connection of actually how far we can push it with as little as really any observations is something that really interests me.
That's interesting what you mentioned. So is Gen AI maybe only the first step to understand the world?
It's definitely not the last step, I think, but it is one that can be very important. I think there's still a bit of a discussion of whether actually you need to be able to generate a video to understand, for instance, the world. Because there are some aspects you might not need, like make an aesthetic video, or like if I give a person now a task of like draw a very realistic image, we probably all struggle a bit. But like currently the image diffusion models don't really have that problem. But I think like it's basically one part, like really, if you're able to perfectly reproduce a world essentially that has all of the physics, it means that you have to understand it. So it is a potential way of actually gaining this understanding and at the same time having also something that can be used for other applications.
That's interesting. Is that the goal of your team, to go in different domains? Because we talk a lot about world robotics models. We had an episode on world welding models and stuff like this. Is this Gen AI maybe the first step to build now bigger domain-specific models when it comes to robotics, when it comes to physics, etc.?
I think it is definitely like a promising direction too. So as an example, when we developed this Nano Banana model, which is taking, for instance, images in and can edit them, we were actually surprised in like also how good this model is in now image understanding and world understanding.
It's always like this. Everybody is surprised when at the end when the model is running, right? So it's better than we expected.
Exactly. It's always like also a bit of like still magic behind it as you start to make the models also bigger and so on. Like it's literally that you can now just talk to it in natural language, and to perform the edits, you need to have a very good understanding. And also, for instance, put now a new head, for instance, on the person's head, but you also need to know, okay, how is the lighting? How is it in 3D working? How is actually the physics behind it? And this is all of these things that the model starts to pick up. It is, at the moment, not as easy to really get this understanding back out. Let's say for robotics, you might want to have it very explicit to then plan your policy of the next steps.
Yeah, CAD/CAM is a big topic in our industrial field. CAD/CAM, it's about technical drawings of some components. I think that's an interesting use case to go in this direction, right?
Yes, that is definitely also a very interesting use case. I think it's Also, generally, what we found is if you build one general model, it is actually very good at also different domains, different applications that you didn't expect. And that is also something that I really like about these big models.
Yeah, but this is the idea of a foundation model, right? So the model has seen a lot of images, a lot of drawings, a lot of 3D drawings. So this is the main idea of a foundation model, right?
Yes. Well, I mean, the foundation model can be either like a starting point on which you then either, let's say, fine-tune it or specialize it to certain applications. Or the other hand, which currently seems also very promising, it's just one model that already does it all very well from the beginning on. And that is indeed like the goal of a foundation model is essentially to be the base and to be actually good at like all kind of domains and generalize across them.
What about let's call it traditional machine learning topics and the traditional machine learning approaches when it comes to, let's say, time series, tabular data stuff? Is that not interested at all in the moment, or what is the problem with this kind of techniques? Why is it not so interesting for you, for your team? Is there a reason for that?
I mean, I think on the one hand, it's of course, where do you have like a lot of data and a lot of easy data to train on? So especially these Gen AI models, we just need observations. Essentially, you just take text, you just take videos out there, which is then very easy to get a lot of data and a lot of scaling. If you, of course, have like more of these supervised methods than before, that, of course, is always of a data question. But I agree that there are like still more domains out there that potentially we are currently focusing on. So things like the time series, also tabular data. I think it's at some point, it's also that most of the communication, basically, let's say with humans, is also happening in a natural language. And this is something like a very strong, actually, communication media that you can do. And there's then also the potential that, okay, once you have like a LLM that is able to communicate with all sort of APIs in a way to become basically an agent, you can also make it easier actually understand different formats, let's say, for instance, tabular data, and have it added and interact with it.
So the idea is to add traditional models to a agentic AI model.
I think that will be basically quite a strong combination because on the one hand, these Gen AI models are quite good, but if you now give them like a huge multiplication, which is very easy to do in a tool, basically just call your calculator, these models can still struggle because they're also not fully deterministic. So I think this combination of actually tools which we already have, which we know are quite good, and just a general agent to be able to actually interact, understand what to do next is kind of a very powerful combination to go forward.
You already mentioned the topic of agents. And from my point of view, this is not a new topic, right? So we are discussing the topics of agents, I think, since the 19th in an industrial setting or in a software setting. So what is, from your point of view, so different to the discussion we had in the last 10, 15, 20 years when it comes to agents?
I think what really changes is that these models are just becoming more general and being able to essentially understand all sorts of domains. So the fact that basically they can take in now any natural language, or for instance, a lot of these now computer use models, which literally can just take your screen and then interact with a web browser the same way that we do, is something that really starts to pick up and is now a powerful tool. Because
do you use agents in your daily life?
Yes. So, well, let's say at least here at work, it's not a secret that we are also using our own models, for instance, in our coding environments.
Oh, I thought you'd. Okay.
So it's essentially definitely like a helper. And also like outside, there are a lot of tools that actually use LLMs as agents for coding. And this is definitely something that is very helpful. I think outside of work, I haven't been using them too much yet, but there are definitely applications that I would be curious about. But yeah, I think it's currently like the strongest that I see is coding for myself, like as a good use case.
Okay, but we have a lot of discussion because you mentioned now we are scaling. When it comes to agent, maybe we do not need these big scaled models. What is your opinion on that?
I think it's kind of both. So you still need a good base agent to understand actually what is going on. Let's say, for instance, if you're doing coding, you will get error messages. And these error messages you also need to understand. You need to debug. You need to go down, where's actually the bug and how can I fix it? And these kind of capabilities will still benefit from scale. As you become larger and larger, Just you're basically able to understand better. You are able to probably fix things easier. So there's definitely still basically benefit of scale. But I agree, if you now compare essentially a giant model with no tools, with no agency, compared to a tiny model that has the access to different tools, there are several cases where basically then the tiny model with tools can beat the giant model. But basically then giving the giant model the access to tools just gives you the benefit of both.
You mentioned these giant models. Do you see an end of this scaling? Is there enough data anymore? Is it new data sources? What about this topic?
I think that is always like a nice creative way of also, that I've seen here in Gemini, is just always when you start to hit a problem or hit a wall, then someone comes up always with like a good new solution that actually is able to get around. So far, it's like I haven't seen like one key problem where I say, okay, this definitely now means we cannot scale beyond. I mean, compute is increasing every year, and we are basically increasing always the scope of our models by every year. They become more capable, so that at the moment, like, these models can probably still benefit even more from scale.
But where do you see limitations?
I mean, of course, if we want to now apply it to different use cases, if you have, of course, a smaller model that makes it on one hand much more efficient, we can start to actually put it on devices and all of these things that currently are just a blocker by going so big. And it's also like one handle of just making bigger, but maybe there are also like new just ideas, new approaches that we actually need to go even beyond it.
So it's the end of the bitter lesson. Stop scaling, think about new methods.
Well, I think it might be also that we just need new methods that work even better with now giant models. Because let's say, for instance, 4 years ago or so on, when really the pre-training era happened of just scaling larger and larger next token prediction, I think people were also like, okay, at some point we'll just hit a wall of next token cannot go further. But when the whole regime of basically reasoning and reinforcement learning came, and that gave us like another big push. And of course, we still benefit of having large models.
And now the Samsung, the very small model, the very tiny model they announced, a very interesting approach to do that. So maybe we should think about new architectures, new ideas, how to handle these giant models.
I agree. I mean, it's at least once we start to go like to more on device and being efficient, I think a transformer is very good at just being basically a general architecture. We have seen that it basically has very little inductive bias, and it just means that as you start to go bigger with also data sets, this is actually easier to adapt. While for smaller models, you can still benefit from having inductive biases. And this means that you can really benefit of having different architectures, also specialized architectures for your applications.
Can you share some? What are you looking into? Is it RNNs or is it a totally different approach?
I mean, I cannot like share, of course, the full details, but it's
yes.
something that we do like. We look broadly at different applications that are out there.
So hybrid solutions, hybrid architectures.
For instance, I mean, I think everything is on the table. Like, this is also the nice thing of generally like having such a team here, that you can always propose things, even if they might at first look very weird or not intuitive why it should work better. But if you are able to demonstrate the performance, then basically we are not objecting to any new architecture. So if, for instance, RNNs, I mean, they have, of course, the big benefit of having like a limited, or basically they are easy to constrain in terms of memory bandwidth, because they have in one state compared to now transformers, which always usually scale more quadratic with a sequence length. So there's definitely like, depending on the applications, different approaches are being taken. And I think we were still not at the end of actually exploring all of the domains, especially then for these small models.
Which areas of AI, except from Gemini, do you think are worth pursuing further? Can you share some? What do you see in the US, in Silicon Valley? Which topics are very hot?
I mean, of course, like Gemini, I think is still the big talking point.
Really, it's still okay.
Yeah, I mean, I think what people are starting to do, like a lot more, of course, application focused. Let's say for like the last 2-3 years, there were maybe still a focus of like having one general model doing it all. And I think especially like Gemini is still one of the parts that is pushing that. But I see more and more that like different startups or different companies start to specialize more for different domains. And one is definitely like this agency and computer use that is going into. Another thing is just going towards industrial applications, so like chemistry, material design, and all of that sort of things. And I think overall, this is just with bringing now actually the technology closer to industry and actually to applications is a big push, and that will continue probably.
When you mentioned chemistry, for example, specialized, we had an episode with Schalker, and he is doing exactly this. And he said, yeah, we need models for chemistry, for biology. How do you train these kind of models at the end? Is it a totally new training because you need a totally new instruction tuning, etc.? So can you share from a Gen AI researcher point of view, how difficult is it now to adapt these technologies to a, let's say, chemistry model?
I think I was always surprised in how easy sometimes it is these models actually to adapt to them. So we know that the base architecture, for instance, a transformer, is very applicable.
That's fixed, right?
But at least like very applicable. Like it's now a default solution, but of course, like if you have very certain domains or restrictions that you have, you might still want to look beyond. But then a lot of improvements, for instance, that we are doing in Gemini on that side can be directly downstreamed to these applications as well. Like there's still also the difference between having specialized models, so models that are really just for your domain of, for instance, chemistry, versus when taking, for instance, now Gemini LLM and trying to change that, as you said, either instruction tuning or try to actually have like fine-tuning data specifically for these science applications. At the moment, I think we were always, or like initially, a lot more was going into then these specialized models. But we have seen that, of course, like as these LLMs start to grow, they have actually a lot of broad knowledge behind it that you can really start to really leverage. And at the moment, like I think there's still the two approaches of seeing, okay, how far can we actually push the Gemini LLM domain of either basically specialize it on data that we have, on potentially also training it basically on agency, like giving then tools specifically for your chemistry domain, versus when having really a specialized model for it. And of course, it's also depending on what compute you can spend. Like one big model that is very general can, of course, then take resources from several teams to make it also very large, versus when if you have a specialized model, we cannot spend the same compute on it, even if we wanted to. So there's always a bit of a trade-off between these two sides.
You mentioned that Gen AI is still a hot topic in Silicon Valley. What else do you see in the US?
I mean, we're of course not just, let's say, Gen AI. There's a lot of other things going on. I think one thing I'm also always still curious is about like the ML fundamental theory behind it, for instance, optimization, which is still something, of course, that is also going strong. Like as we are starting still to like, on one hand, of course, it's still about big models, but it's not necessarily about just this objective. It's also then of how can we actually understand these? And on the other hand, of course, with the understanding is also a lot of alignment, AI safety, which is also like becoming a bigger topic just because these models become more general, which means they are basically much more coming into our daily lives. They have access to a lot more things, so you also need to know how to actually steer them.
Oh, is that a topic in the US, the safety topic? I'm surprised now a bit.
I think it is still like a very relevant topic. I mean, it's of course, different people are like differently deep into it and really saying we already have to stop versus like it's not really at that point yet. There's
greetings to Gary Marcus, right?
Yeah, for instance, that is one very prominent figure in that domain.
Yeah.
But it's, I think, like both sides have it good points. But on the one hand, we haven't hit a wall yet. Like these models continue to improve and improve.
So what is it at the end? So Sepp always tells us it's a database technology. Maybe it's more. But where do you see it between it's a database technology and AGI? Where do we stand there?
I mean, on the one hand, it is, of course, a data game. Like, the better you have the data, the cleaner you have your model. But I don't think that this is, like, the whole story. So, for me, basically, one big hope or one big vision at some point is that I would like to have a model which I literally just can say, okay, train yourself now. So, basically, I just deploy it on a compute cluster. I don't really have to give it data. I might just give it, basically, solve, basically, a math problem that humanity hasn't solved yet. And then I just basically let it learn itself. And after, if it basically comes out with a solution, it not just gives out the solution, but actually has learned from the process of developing it, such that if you give it another related topic, it will actually like solve it even quicker. And at the moment, still, even with reinforcement learning, we usually need to have like a set of prompts, riddles, and so on which this has to be trained. But ideally, like I would really like to see these models just take off with as little data as you need to. Just basically they train themselves, because that means when we just, depending on how much compute we forward them, they get better. We don't have to worry about still providing better data or running out of data. And then there's potentially like no limit in how far it can train.
Wow. Okay. What is on your desk after this recording? What do you need to do in the next weeks?
I mean, on the one hand, of course, we want these models to become, of course, better and better. Like one thing is our nano banana model, for instance, which I was working on. And this is something that there's still a lot of things that we know actually have to be or can be improved. And this is definitely can be improved. And this is definitely stuff.
What can be improved?
We are quite decent in keeping, like, for instance, your face, your character consistency, but it still doesn't work like 100% of the times. Like sometimes also the model just doesn't understand really the edit and returns almost to original image. And that is something that we definitely are improving. And now that we also have seen what actually, for instance, users are using it for, like what people are interested in to use these models, it's also for us when like a feedback of saying, okay, let's actually see if we can focus and also improve in certain things. Because it is still like super useful to many domains. It's also like for our daily lives, like how many people just generated fun figures or put themselves into fun situations. This is also something that's actually nice to see, that now basically you're working on a project and on a model that actually is used by so many people, and also basically brings them a bit of joy and fun into the daily life.
You mentioned you're a researcher. How many papers do you read in the week?
That's a good point. So I think since I definitely moved from academia to industry, I started to read less or fewer papers behind it.
Yeah, okay.
But it's also not that I basically completely ignore it. So we are still having also discussions on basically new papers going on. Let's say for me, it's probably like I still check 3 or 4 papers per week.
What was the last one you read and said, oh, that's an interesting idea?
I think at the moment it's, of course, like I'm also, since Nano Banana is essentially this multi-model domain, I am also more checking this domain behind it. And it's always creative to see what people really come up with, especially also on the side of benchmarks. So for instance, people were trying to use when Nano Banana and the other image generation models on like complex physics or science problems of like, okay, here's now the input, now show me basically the solution as an image in there. And that is definitely something that also from a, like even if a paper is like more on the benchmark side, it actually shows us also like, okay, what capabilities these models have and what downsides they still have.
I think the whole community is so much focused on leaderboards, benchmarks. Everybody is staring on these topics and looking at the leaderboards, what is happening in the leaderboards. That's absolutely crazy to see that. And sometimes they improve their models only for the leaderboard. What is this in this community? Why is it so focused on these leaderboards?
Yeah, so it's definitely also, I think, a sort of a problem. Like there was recently a benchmark coming out, for instance, for which models can read the clock correctly. And we know that actually like a lot of multi-model models are still struggling at that. And we always use like more this reading a clock as like a hold out example set of like, okay, as you start to scale, like, oh, this is one that we are still failing on, and a general model should not fail on it. But now that it has been becoming basically a benchmark, people can now start to potentially put like special data for it in your data set.
Exactly.
And then you just basically fit one hole and you're very good on that task, but now actually this task becomes irrelevant because it's not anymore measuring how general you are. So this is definitely something that is always dangerous to do. But at the same time, it's good to have benchmarks, because benchmarks also is then a way of us to check, for instance, okay, do we actually improve? How general are these models? What are obvious things that are still not working? So I think there's a bit of a balance that, of course, like you shouldn't take the benchmarks then 100% serious, because most of them you can game. You can just train exactly for it. But if you basically don't do it, if you just see it as an evaluation metric, they are still very helpful and actually show us like where are still the limitations of this model.
Yeah, and the real world performance is still different, right? So when it now in the nature, the model performs totally different and not as sometimes as it is in a leaderboard or on a benchmark.
Exactly. And it's also just for us, for instance, seeing how users interact with the models are often different than how we intended it in terms of our evaluations. So it's also, for instance, people put in ambiguous question or basic queries and so on. And all of that you now need to handle. And sometimes benchmarks are not really reflecting it. And the other thing is, of course, like on the one hand, you can have like a really smart model, but if it's just bad at communication or like has not really a persona that people want to talk to, then in the end, like you can have a very smart model that is really good on benchmarks, but actually interaction wise, no one really likes it, or potentially it's also not general. Like these things can always happen that you're really good on benchmarks, but now on more real world use cases that you didn't really think was like a big target, suddenly your model is not performing as well as you expected.
Absolutely. Last question, and maybe the most important question, Philip. Do we will see Schalker next year in the first league again?
I mean, they started very promising actually this year. I expected it actually. Like it's really nice for a change to see it. I mean, I'm hoping for it. I mean, my family is living very close to the stadium, so I am probably also visiting again over December, like just.
So you follow the match days?
I mean, at least I follow the outcomes. I'm not like watching them live, also because it's like in the middle of the night for me by now.
Exactly.
But it's still like it's always a nice connection also with my family.
Absolutely
like chatting about it, so it's always like a nice connection still from where I came from in that sense.
Perfect. Philip, when you will come back to Europe, or will you stay in the US?
I think my goal is actually to come back to Europe. It's at the moment just so the reason why I really started here in the US is simply that a lot of these hubs, a lot of the center is at the moment still here in California. And if you want to really start at the heart of it and be part of the main movement, like it was kind of the best choice for me. Also, like looking back, actually coming here was a very good decision. But once I basically also am more comfortable and basically had enough impact that I also see like, I mean, I would like to see more from Europe also coming out, like that we start to also have more hubs there, more focus. And that's something that I also see myself more than moving back basically to Europe in a couple of years. And let's see what the state is there. Maybe we already have and some more of European unicorns really coming out and what we can push also beyond basically here the US focus.
Keep fingers crossed. I'm really looking forward to meet you. Maybe do you go to Europe or is it not interesting anymore for you because now you have a big research team at Google Research?
I mean, it's both. I think I will still come to Europe. I will try to. But it's definitely like a bit of a change that not potentially everything at a conference is still 100% like the focus of us, because of course, academia is still much more broadly, and there's not too much that academia can sometimes do at the scale that we're doing here. But it's still very relevant. And I mean, I love to be at Europe and also catching up with a lot of people from my time before in academia. So it's always fun to also just meet up again.
And talk about Schalke.
Yes.
Maybe we will see each other. Thanks a lot, Philip. It was a pleasure to talk to you.
Thanks so much, Robert. It was really fun.